Assalamualaikum and a very good day. I would like to introduce myself first. My name is Amirul Amin bin Nur Hilmi. Today, I would like to present my final year project. The title will be The Effect of Gamma Radiation on the Thermal and Physico-Mechanical Property of PMMA Composite. My supervisor name is Dr. Abdul Manaf bin Abdullah. Next, the content of this proposal will be the introduction, problem statement, objective, scope and limitation, literature review, methodology, and last but not least, preliminary result. Next, we move on to the intro. Polymetal metachloride PMA was first discovered in 1901 by a German chemist named Otto Röhm. This discovery has made a change in wide application in the world today. One of it will be in the medical field, where PMMA is applied as dental cavity filling and bone cements. This polymer is being used mainly because its property where PMA has high mechanical strength, durable, and last but not least, have good UV stability. Despite that, the downfall of the polymer include poor impact resistance, limited heat resist, and lastly, prone to wear resistant. Researcher had made study on how to improve the property of the PMMA. One of it will be the adding of inorganic filler into the polymer. Uh, for example, the addition of zinc oxide to the polymer will increase its properties. On the other hand, my study will be further the process where the composite will be exposed to gamma radiation and the effect will be seen after the study had made. Next, we move on to the problem statement. As I told earlier, the first stage of the study include of the addition of inorganic filler with zinc oxide to the PMA composite. The study has found that zinc oxide has good UV absorption property. This will then improve the mechanical, thermal, and electrical property when the material is mixed with the PMA, producing PMA composite. This study focusing on the second stage where the zinc oxide is treated with gamma radiation, where gamma radiation is said to be enhance the activation energy of the material. So the effect of the property will be studied in this project. Next, for the objective, first is to investigate the effect of gamma radiation on the morphological property of zinc oxide. Second, to assess the effect of gamma irradiated zinc oxide on the mechanical and physical, and lastly, thermal property of PMA composite. And lastly, to evaluate the effect of gamma irradiated PMA composite on the mechanical, physical, and thermal properties. Next, for the scope and limitation of project will be this project will undergo two stages, where the first stage where the zinc oxide is exposed to gamma ray and the morphological property is assessed. Next, the second stage include the PMA zinc oxide composite to be gamma ray treated and the physico-mechanical and thermal property to be evaluated. The limitation of this project will include the ability of equipment in the laboratory, where the oven in the polymer lab in your ATM not function properly, as the sample need to be undergo curing process at 55 degrees Celsius to allow complete polymerization process. And next, the gamma treatment will be conducted at Nuclear Agency Malaysia in Kajang, Selangor. The dosage of radiation may be not same as the other study where it was done in overseas. Hence, the level of dose will be the concerning parameter as the treatment can only be done on specific level of dose. Next, literature review. In the electromagnetic spectrum, gamma ray is the smallest wavelength and the highest energy produced by radioactive decay. Gamma ray are used in medical process where sterilization process is made possible because gamma ray can kill microorganisms without damaging the equipment. Next, for thermal property of irradiated PMMA. Research found that composite with the addition of filler like zinc oxide, aluminum oxide, and others made thermal conductivity of the composite better compared to a pure PMMA. On the other hand, the thermal conductivity of irradiated PMMA show a decrease in value of thermal stability. Lastly, physicomechanical property of irradiated PMMA. Gamma ray show that physical property of irradiated PMMA increase due to cross-linking and surface modification process. A test on aluminum oxide showed a dose of 25 kilogram of gamma ray improve the tensile strength of the composite. Next, for the metallurgy, the process flowchart on the right show on how this project will be done. First, zinc oxide powder will undergo gamma treatment and the morphological property will be studied. Next, the irradiated zinc oxide will be mixed with PMMA to see the physical, mechanical, and thermal property of the composite for the second stage. The test will be conducted with different composition of zinc oxide. Lastly, the third test will be the mixing of PMMA and zinc oxide. But here, the zinc oxide will be chosen from the best, showing the best result in the previous test. This later, the PMMA zinc oxide composite to be gamma ray treatment and the properties in terms of mechanical, physical, and thermal will be evaluated. Lastly, the result will be documented in indicating that the process is done. Preparation of PMA and PMMA zinc oxide sample. PMMA powder will be mixed with PMMA liquid at a ratio of 1.5 gram, ratio 1.1 milliliter. The mixture will be poured into a silicone mold to form the tensile or flexural template. Next, the silicone mold will undergo curing process where the silicone mold be placed in oven at 55 degrees Celsius to allow complete polymerization process. Lastly, for the preliminary result in FYP. I control lah. Lastly, the preliminary result in FIP1. Tensile test was done on the PMMA specimen. 3 PMMA specimen will be produced and undergo the tensile test. Firstly, the specimen will be measured using vernier caliper to see the dimension of the specimen. Next, using the tensile universal testing machine, the specimen will be loaded in the machine and wait until the specimen to be fractured. The 3 sample will be undergoing the test and the stress and strain of the specimen is tabulated from the data. It shown that the specimen one having the maximum stress compared to the other 2 specimens. The mean calculated from the 3 specimens show that the maximum stress calculated is 52.89 megapascal and the max strain calculated is 7.03%.